Okay, I was getting all jazzed up to do this video, and I think I basically already did it. So this would have been in the 10.1 video where we really went into this. But essentially the idea is comparing the angular and linear variables. So this is where it's trying to make that connection that, look, they're just like us. So again, that concept of angular acceleration. So, say I'm given a wheel that's spinning and I'm given some kind of an omega that's spinning. So I'm given an angular acceleration and a angular velocity. So if I'm going to be talking about what that piece is doing, that particle is doing, the particle has a velocity of omega times r. Now we talked about it's actually omega cross r to get the right direction, but if we're all in 2D, and I think everything in this class is in 2D, then we're good to go. And then if I wanted to know what's going on with the acceleration of the system, that the acceleration in this direction is acceleration tangential direction is alpha r, and the acceleration toward the center of the circle is omega squared r. Okay, also known as v squared over r. So either one of them works. And again, if you ever need to convert between roundy round and lefty righty, you can think about S equals R theta. So that's kind of your conversion. That's your local guide that can help you go in between the two languages or the two spaces. So it's kind of like, if I had a block here, I don't think you're going to do anything like this, but if you had a block with forces, going this way and forces going this way, then, F equals ma in this direction, F equals ma in this direction, you would use tangential acceleration. F equals ma in this direction, you would use either of those for acceleration. So really it's just super cool that all this accidentally works out. And it's not an accident. People spent their entire lives figuring this out. Another thing that they might get you on is like, well, what's the magnitude of the acceleration? And remember, since an and at are perpendicular to each other, that the magnitude of acceleration as a whole is just the square root of the sum of the squares, because it's really just a triangle. So I have a tangential component and I have a normal component. And if you remember, like years, what seems like decades ago now, we would draw in the resultant like that. And it was the, it's a Pythagorean triangle. So square root of at squared plus an squared. And then you could get the theta by, well, depending on which theta you're trying to get. But this particular theta that I drew would be inverse tangential over normal. But obviously if you're looking for the other theta, then you would flip the tangent. So I think that's about all they're going to ask you to do here. And then they'll have a couple of problems. But yeah, do you see how they've got the, they're not calling it normal and tangential. They're calling it something else. They're calling it C to the center. Okay, they're calling it C to the center. Okay, you can handle that. You're a big giant person who can handle things. There you go. And this is pretty great. So basically everything that you learned how to do lefty righty, you can now do roundy roundy.